Good afternoon, ladies and gentlemen. In this short video, I'm going to do the problems for practice A in chapter 14. So it starts on page 514. There's number 10, 11, 12, 13, 14. So the P word is practice, practice, practice. We go through all these problems and you're going to be really, really well versed on Snell's law. Snell's law, which you'll be working with on your lab. Okay, the first one, number 10, light passes from air into water at an angle of incidence of 42.3 degrees. Determine the angle of refraction in the water. So I tried to draw this. Let's see, I'll turn off this light, make it bigger. Here we go. All right, so on this part here is air, and then this part here is water. That's down there is water. So we have a light beam, think of, and it's 42 degrees with the normal. So remember, the word normal also means perpendicular. So we're always going to be dealing with what degrees is it away from the normal. So I drew this line, the one straight perpendicular here, this one right here. And so 42 degrees from the normal is that angle of the line that's coming in, the light ray that's coming in into this water. 42 degrees, that's supposed to be straight. So the question is, that's the incidence, angle of incidence. Angle of incidence is 42.3 degrees. So the question is, what angle will it be to the normal, to the perpendicular, when it hits the water? Remember, the reason why it bends is because the speed of light changes in different media. Okay, it's going to slow down in water. So it has to do with the index of refraction. Index of refraction, we call that little lowercase n. So the index of refraction of air is pretty close to 1.00. I think there's a couple more zeros and then 4.3. So we just rounded to 1.00. Probably should be 3 zeros, because the index of refraction for water is 1.333. So the question is, what is that angle? So I draw your attention to the handout that I made for you guys on chapter 14. And 3/4 of the way down, I have a summary of Snell's law. So here's the light, and then it's a dashed line here, perpendicular, and it's going to something. Maybe it's a block of glass, some other medium. You'll notice that it doesn't go straight through, but rather it bends. And we describe it by what degrees away from the normal. So there's that should be theta I for incident, angle of incidence. And here's theta R, the angle of refraction. And Snell's law says that if you multiply the index of refraction of the first media times the sine of the angle of the incident angle, that's equal to the index of refraction of the second medium, where it gets refracted, times the sine of that angle refracted. And that's all we need to figure out. We know what this is, we know what this is, we know what the incidence is, so we can figure out what the sine of the angle refracted is, and then take the arc sine or the inverse sine. Okay, so take a look here. Here we are. So I'm going to write down that equation that you know from Snell's law, that the incident refraction of the media incidence times the sine of the angle of incidence, that should be an I, is equal to the index of refraction of the second matter. I'm going to say that's the refracted one, times the sine of the theta of that angle. So in this case here, this one's going to be the water and this one's going to be the air. So and we know what this angle is. Well, we can take the sine of it. So all we need to do is, what is the angle of the sine of the refracted angle? So to figure that out, I just have to divide n sub r to both sides. I'll do that. So n of the incident times sine of the theta angle of incident, all over n over the refracted, is equal to sine of theta r. I'll put that over here. Sine of theta r. Okay, so all I did was I divided n sub r to both sides. Okay, now I can plug it in. So n of the incident, that's 1.00 on the top. 1.00 times the sine of the angle, which is 42.3. Sine of 42.3 degrees. All that divided by the other index, which is 1.333. And that'll give us the sine. Let's see what that is. I'm going to put it over here. All right, first I'm going to take, and I'm going to ask for the sine. Give me the sine of 42.3. All right, so there's the sine. I multiply it by 1, I would just get the same thing. And then I divide it by 1.3333. Divided by 1.333. And that gives me 0.50488. I'll write that down. 0.50488. That gives me the sine of theta r. So what is theta r? Well, it would just be the arc sine. The arc sine, which we say inverse sine, the sine to the -1. So I'm going to say, give me the sine, which I have to hit the green button. Give me the arc sine, please, of the answer from above. And there we go. It's 30.323. So we'll just say 30.3 degrees. So that's the answer. And now we know exactly that it bends so that it's further out, 42 degrees, and it's going to be closer into that normal line, which I highlighted as yellow. So this guy now is 30.3 degrees. I think that answers the whole question. All right. So just ask for light passing air to water at an angle of 42.3. What's the angle of refraction? So we just applied Snell's law and we solved for the sine of the refracted angle, and then we took the inverse sine. You hear both terms, inverse sine, you hear arc sine. All right, let's take a look at the next one. The next one, number 11. A ray of light enters the top of a glass of water. Same thing. Let's see if I can put it like this. Same kind of problem here. There we go. All right. A ray of light enters the top of a glass of water at an angle of 36 degrees with the vertical. What is the angle between the refracted ray and the vertical? So same thing. We've got the same kind of scenario. We have air. This is inside your glass. And when it hits the water, oops, then it hits the water inside your glass. So with the vertical, the angle is 36 degrees. I would say that that right there is 36 degrees. That's my angle of incidence. So the question is, what is my angle of refraction? Okay, air, we know that the incidence of air, put that here, is 1.00. And the incidence here of the refracted material, where it gets refracted, of water is still 1.333. There's a table in your book with a whole bunch of different kinds of materials and what the incident refraction is. All right, so here we go. The incident index of refraction times the sine of that angle, the incident angle, is equal to the index of refraction material times the sine of the refracted angle. And we want to know what this is. So let's solve for sine of theta r. So here we want to solve for sine of theta r, then we can take the arc sine. So again, we're going to divide both sides by nr. Divide both sides by nr. N sub r. Yeah, because this cancels out. All right, let's plug it in. So in the first case here, we have 1.00 times the sine of the angle of incidence, which is 36 degrees, divided by water's incident of refraction, 1.33, or rather index of refraction. All right, let's see what that is. Here's my calculator. All right, sine of 36, and I want to divide that by 1.333. There we go. So this equals 0.4409. Okay, so that is the sine of my refracted angle. So the refracted angle is the arc sine. So I take the sine to the -1 button. See how it's green there? And give me that of the answer above. And there it is, 26.16 degrees. 26.16 degrees, so we can say it's about 26 degrees. So we know that this got bent, was 36, and then this became 26 degrees. to the normal, to the perpendicular. All right, let's move on. Let's read the next one. All right, in this case, I think they give it to us the other way around. Let's see if we've got enough room here on this paper. A narrow ray of yellow light from glowing sodium. By the way, there's the highway lighting, lights that you see out along the freeway. Some of them are low pressure sodium, high pressure sodium, for actually to make the illumination. So that's why it is sodium. And they give you the wavelength. It's 580 nanometers. Isn't that interesting? Okay. Traveling in air strikes a smooth surface of water. So again, we got air and water at an angle of 35 degrees. And they even put the little I for incidence. Determine the angle of refraction. So we got the same thing, except that instead of white light, it's going to be yellow light. And we have air here, and we have water here. And again, of the water, it's going to be coming in perpendicular, and we have 35 degrees. There we go. Let's say that's 35 degrees. That's my angle of incidence. So I want to know, what is my angle of refraction? What's that guy? Same thing as we did before. I'm going to write here, n of the incident times the sine, the angle of the incident is equal to n of refraction times the sine theta refraction. Again, I want to solve for the refraction, so I'm just going to divide both sides by n sub r. N sub r cancels out. All right, so now I have sine of theta r, ni is 1.00 in the air, times the sine of, what's my angle here? 35 degrees. And the other side is water, which I didn't write down here. The water here is 1.333. So 1.333. And that's going to be the sine of the refracted angle. So let's take a look at that. What that is. I'm not going to multiply by 1 because it gives me the same thing. There we go. Sine of 35. There's my sine of 35 divided by 1.333. There it is, 0.403299. 0.403299. Okay, so I want to do the arc sine of that. What's the arc sine of that? And I get 24.485. So theta r is 485 degrees. So I'm just going to round that off to about 24.5 degrees. So I know that this is 24.5 degrees. So that's how much it got refracted. Okay, that was number 12. Let's move down to number 13. I think you're getting the pattern here. Let's turn the page. All right, number 13. There we go. Okay, this one's really fun. Let's see if I can draw it. Trying to get, if I can just get that part. Not letting me easily fold this. Okay, let's see. Hopefully you can see that. A ray of light traveling in air strikes at a flat 2 centimeter thick block of glass. And they tell you the incidence of reflection for the glass is 1.50 at an angle of 30 degrees with the normal. Trace the light ray through the glass and find the angles of incidence and refraction at each surface. So they're like at each surface. So I better draw something here. I'm going to draw here. This is my block of glass. And this is supposed to be 2 centimeters. Okay, from here to here is 2 centimeters. Obviously not drawn to scale. Okay, and so what do I have here? I have air here. And then in here I have glass. And if the air is I'm going to draw my orthogonal. Orthogonal is another word for perpendicular or normal. Okay, so I'm going to have air come, or a ray of light coming through the air. Then it's going to hit the glass. It's going to get refracted. And then it's going to continue to the glass, but then it's going to go out of the glass and back to the air. Okay, so let's see. The first angle it says is 30 degrees. 30 degrees, 30 degrees. So I'm going to draw a 30 degree. Let's see if I can use it. My straight edge here. 30 degrees. Remember, there's 30, 60, 90. So it's about, if you not to scale here, I don't have the room for this. All right. No, it's not to scale. Sorry. This is going to be 30 degrees. At least it's straight. So that's my first angle of incidence, 30 degrees. Now we need to figure out what angle is going to be at the glass. I'm going to assume it is going to bend. Here, go ahead and write down. I'm going to go ahead and write down. Here I know that the incident is index of refraction is 1.00. This one tells me the glass is 1.50. So here it's 1.50. But then when it leaves the glass, it's going to go back to 1.00. All right, so we want to know what this angle is going to be that gets refracted. So just like we did before, I'm going to put here n of the first one, incident sine incident is equal to the n of refraction times the angle of refraction. I want to know what the angle of refraction is, so I'm going to divide n sub r to both sides, n sub r to both sides, and I get sine of theta as a refraction. So we plug that in, I get 1.00 times the sine of 30 divided by n of the second one, the refracted, that's 1.50, 1.50. And that's going to be the sine of theta refracted. So let's figure out what that is. Happen to remember that sine of 30 is 1/2. So if you don't believe me, sine of 30 is exactly 1/2. Okay, we multiply that by 1, and then we divide it by 1.5. Divide that by 1.5. There we go, 0.333333. Exactly, 0.333. All right, so now let's figure out what the angle is of refraction. Say, what is the arc sine? What is the arc sine of 0.33333? And it's 19.47. 19.47. 19.47, so I'm going to round it up to 19.5. See, it's 19.5. So it's a lot tighter. So this one is 19.5 degrees. But it continues all the way through. So this is here, and then it continues through. Obviously, it's not to scale here. It should be a little tighter here. All the way to the rest of the glass. And the question is, then what is the angle again when it leaves the glass? And I'm drawing another line perpendicular because everything's always to the perpendicular of the surface that it's hitting. So what is this angle now? This second one, I'm going to call it theta 2. What's that one? Well, hopefully you're reading your book and there's something called reversibility of refraction. It's going to be as if it didn't go through the glass. It's going to continue. And you can do the math and prove it to yourself, but it's going to be exactly what it was before it hit the glass. It'll be 30 degrees. So this one's going to be 30 degrees. So the first one is 19.5 degrees. And the second one is going to be 30 degrees. And that's going to be something called reversibility of refraction, because it is going to bend back out because it can go faster when it leaves the glass into the air again. So this is air when it hits on that side. All right, so that was number 13. And the last problem is very similar to this one, the one we just did here. And the last problem, here we go. The light rail shown in the figure below makes an angle of 20 degrees with the normal at the boundary of linseed and water. Here, this part here, this yellow part is linseed oil. So it starts at air. So here's my light rails going through air, and then it gets diffracted. And notice how it's according to the normal. The normal over here is they're showing is 20 degrees. And then it continues for this layer of oil before it hits the water. And water, of course, has a different index of refraction, and so there's a different angle. All right, let's see if I can maybe write just on this paper. So the first one, it tells you what this one is, 20 degrees, but it doesn't tell you this angle. And then it wants to know what this angle is down here. So we're going to take this one at a time. All right, this guy here is going to be, the index of refraction here is 1.00. This one here, I'm going to call the first one refraction. It says it's, tells you here, 1.48 for oil, 1.48. And here, the index of refraction for water is 1.333. So we have enough information to figure out what this angle is here. All right, see if we can squish this on this paper here. The first one, I'm going to write down here, n of the index of, or in incidence times the sine of the angle of incidence is equal to the n of the refraction times the sine of the angle of refraction. And notice here, the refraction is the 20 degrees and 1.48. So we want to know what this one is, the theta 1, which in this case is the angle of incidence, the first one. So I'm going to divide everybody by n sub I, the first one, n sub air. Divide this one by n sub air. Okay, so now I have the index of refraction here is 1.48 times the angle. Here's the angle, 20 degrees. Sine of the angle times sine of 20 degrees, all divided by of the air here, which is 1.00. 1.00, and that's going to give me the angle of the sine, or sine of the angle, sine of the first of the incident. This right here. So let's see what that is. Clear. 1.48 times the sine of 20. This time I'll close the parentheses. All right, there's my numerator, and divided by 1 is the same thing. So all that is 0.506, 189, etc. All right. So should write it down here. 0.506189, etc. Okay, so now let's take the arc sine. So then I'm going to take the arc sine of this guy. So I say second arc sine of that answer. And I get 30.4. So I know that this is 30.41 degrees. I'll just leave it at 30.4 degrees. So I know that this guy here is 30.4 degrees. And I know that because I know what the index of refraction of these two different media are, and because the angle is 20. So now I want to know what the angle is down here. We're going to do the same thing we've done before, except now we've got 20 is the one with respect to the normal. Okay, so again, here we're going to go n of incident, sine of theta incident is equal to n refracted times the sine of the angle refracted. And now the water is the one where it gets refracted. We want to know this one. We want to know this theta r. So we're going to divide both sides by the n sub r. N sub r, n sub r. And that's going to give me the sine of this angle. All right, so the n sub I is this guy up here, because it's starting in the oil and then goes into the water. So it's going to be 1.48 times the angle here, which is 20 degrees, sine of 20 degrees, divided by the index of refraction of the water here, which is 1.3333. And that's going to give me the sine of my refracted angle. All right, see what that is. Oops, sorry. Okay, let's do the calculator. I have 1.48 times the sine of 20 times the sine of 20, close parentheses, and I can divide it all at once, divided by 1.333. There we go, 0.379. 0.379, etc. Remember, I don't want you to truncate this. Don't want to round this off because you want this as accurate as possible. You only round it off at the very end. So now, what is the angle of refracted? We're going to take the arc sine. Arc sine of that answer above. There we go, 22.3. 22.3 degrees. I'm checking here, 22.3 degrees. And there you have it. And that's it. Okay, so this is a great problem, combining the light going from air, then through linseed oil, then to water. So you see that the light gets bent each time. And because of the Snell's law, it's very straightforward to figure out exactly what the angle is. All right, so that's it. Let me know if you have any questions, if you want to meet with me. Otherwise, I'll see you next time. Okay.